Hey friends, good morning. Today is 20th of December 2020 and Christmas is around the corner. Today in my series of random thoughts, out of my interest and long association with hydrographic surveys, basically for our brilliant younger lot of surveyors and survey techs, I am compiling this discussion on survey equipment interface, data communication and some of its issues. Apart from participating in survey equipment training in various places at various times, mobilizing various survey spreads, I also have been an instructor for hydrographic electronic survey equipments at National Hydrographic School, which now is National Institute of Hydrography at Vasco da Gama in Goa. This is just me sharing my information, training, and experiences. This discussion does not have a scope to provide a definitive response and is not all inclusive, yet it may well shed light on some of the issues of our interest. Let's begin with our legacy serial data transmission. Dozens of serial data interfaces are available today, developed for specific purposes but have found universal application. Let's take the example of CAN, the Controlled Area Network, which basically was for the purpose of auto gear system and automobiles, have found its way in ROTVs, which we predominantly employ in our UXO site surveys. Then there is USB, also the Ethernet and other high-speed interfaces like the Firewire, HDMI, Thunderbolt and a lot others. Basically, the difference lies between the data transmission protocol, the transmission speed, number of masters and slaves it can cater to, and few other aspects. Technically, Morse code can be considered as the beginning of the serial data communication. The two of the oldest interfaces that we use in survey spread are RS-232 and RS-422, and to some little extent its better counterpart the RS-485. Just if you are curious, it's simply the recommended standard. We will hear more of this along our discussion. Serial data communication can be characterized by four primary factors. The first is the data speed, or as we know it, the baud rate. Baud is defined as a signaling bit, which apart from the data bit includes start, stop, framing bit, optional parity bit, and other bits also. As data speeds have become faster, the term baud has been widely replaced by the term kbs or kilobits per second. But for us in survey, it is just that 1000 baud is 1 kbs and so 9600 bauds is 9.6 kbs. As a survey tech, baud doesn't matter as much. It's pretty basic. What matters us though is the baud rate. As we are aware, the baud rate signifies the speed of transmission, which is the number of signal elements per unit time. A baud rate of 9600 means 9600 bits will pass in a second, which means that the length of the bit will be 104 microseconds. Now, why is it important? Because in a asynchronous transmission, baud rate signaling is used for the timing of the receiving data. We will discuss more on the asynchronous transmission in a bit. Theoretically, in our example, with a baud rate of 9600, the receiver after detecting the start bits count 104 microseconds with some plus minus 5% tolerance included, and thereafter it starts accepting the data. If within the tolerance time the data doesn't scroll in, the message is garbled. Now this is the reason why if by any chance the receiver has been set to a wrong or unmatched baud rate, the transmission is garbled. You may well refer my earlier discussion on baud rate on my blog. I will mention the link below in our discussion.